So what makes our robot different? We used a rack and pinion with a servo and a bucket hooked up to the end to collect the ball, to drop it, as well as to push the button for the service station. In order to accomplish this with our limited number of PWM pins, we hooked the stepper motor that was controlling this up to the same pins as the stepper motor that we used to drive the left one. And then we used the enable pins to disable one motor at a time, allowing us full access to the other one and full control over it.
Another unique aspect of our rover is its hard exoskeleton, which it uses to escape from Martian predators. One thing that we found we needed to use for our design was to put extra caster wheels in front and in back of the robot to reduce the rocking due to accelerations on turning and starting and stopping.
One of the biggest things we would change would be to work on the final mission as we went through the milestones. One fatal mistake we made was that as we did the milestones, we thought that we could copy and paste our code together and the robot would complete the mission at the end of the semester. But we were very wrong. We found that once we put our code together, many unforeseen issues arose. One example is that a robot would rock back and forth as we stopped, started, and turned on the course, because our robot was tall and got top-heavy as we put things together. If we found this out earlier, we could have changed the design of our robot to be longer and to keep the weight low to the ground and to be more stable. But it was too close to the final mission to make such a big change.
Another thing that would have made this project easier to do and more manageable would be to 3D print more parts that were more modular instead of using just a wooden board that needed to have things screwed into it over and over again.
We do improve our wiring to make it cleaner. One way we could have done this was to make PCBs for our QRDs. Our team used a lot of QRDs, which led to a lot of wiring, and using a PCB would get rid of our QRD rat's nest and avoid making mistakes in wiring multiple QRDs. Another major improvement that our team would change is our debugging process. Throughout testing, our robot ran into a lot of problems with switching states and doing different tasks. One thing we would change in our debugging process would be to use LEDs to indicate when our task detection QRD would go off and to indicate which state of our robot was in. For example, we would set up 5 green LEDs to indicate the task state the robot is in. We would also use different color LEDs to light up when our task detection QRD detects a line to tell when or what state it was sensing while it was on the track.
Rather than having a rack and pinion on our robot like we had, next time we would rather have had a telescoping arm, which both would have been more compact and allowed for greater reach. Having the rack and pinion extended the width of the robot and made it more difficult to navigate the canyon without bumping into walls. And here's the intro part. Hello, my name is Ryan Hansen, and I was on the 104 Days Mechatronics team.